Welcome back everyone again. Let's use recursion to solve problems with binary search algorithm. Okay. Now from the last class, I believe you guys understand what binary search is, isn't it? And we were able to write an iterative function to solve binary search, isn't it? Okay, good. In this class, we will use recursion. How? First thing, we need to determine what? The base case, isn't it? We need to identify the base case. What does base case means? The condition for what to end. For it to end. For what? For the function to what? The terminating point, isn't it? For that function. So the function does not keep recalling itself, isn't it? So if you look at terminating point, what does that mean? When you terminate the function, what does that imply? When you get what you are looking for, then the function should terminate. What other reason should the function terminate? You tell me. So, like you guys have told me, there are two conditions to terminate this function. When the item is found, or when the item is not found after you've searched through all the what? All the portions, all the indexes of the array, or after you have searched through all the array, right? If you search through all these positions of the array and you couldn't find your target, should you still continue to search again? No. Is that understood? Then those two conditions should form your base case. That means base case may not necessarily be one condition. Is that understood? So we said that the base case is if the search item is found in an array, or what? If the item, that is the search item, is not found, and the what? The array is completely found. So that means you can have as much conditions in the base case. Not necessary to be what? To be one. Is that understood? So what is the second thing you guys must identify before you write your code? The recursive case. Okay, the recursive case. Now tell me, how do you identify the recursive case? So like I said, your recursive case will be determined by 2 points. If your item is not found, remember in our last class, if your item is not found, it is either we check to the left or to the right. So that means the left and right is that point where you have to recall your function. Is that understood? So that means we have to check to the right. If search value is what? Greater than the mid value, or you search to the left if search value is what? Less than mid value. Is this understood? So whether you use less than or greater than depends if the question is what? Ascending or descending. But you must understand that if your value is not found, fine, we know the recursive case is if the value is not found. But why is that point if the value is not found? So you cannot just say if the value is not found. Yes, we know. Where is the point specifically? So you have to specify that you have to check to the right, then you call the function, check to the left, recall the function. So with this, the recursive case has been defined. So while defining the recursive case, then I have to write more information to assist myself. Is that understood? So going to the right, what does that imply? When you find towards the right, what does that imply?
It means that the search item is
lower. Is that understood? So that means that when you search to the right, it implies that the lower boundary will be equal to what? Mid plus 1. Is that understood? So you must identify that in your definition. Okay? When you are searching to the left, what does that imply? The upper boundary will be equal to what? Mid minus 1. So now that you now have your blueprint, now you can write your code. Don't write your code except you have identified this. I'm not just talking about binary search. I'm talking about all questions that you can come about. Whether it's linear search, binary search, compound interest, simple interest, or whatever, even insertion sort, binary sort, whatever the question. It may not even be an algorithm you are familiar with. They might just give you an iterative function. Anything, it may not be something you know. They'll just give you a function that is iterative and ask you guys to write the equivalent recursion. Yes, you can receive that code. It's in the past question, although written in pseudocode. I can also give you in Python, give you any iteration. It may not be anything you've studied, just a code that implements iteration. And you are asked to write that in what? Recursion. So first thing is to understand the blueprints of how, or show it mathematically or whatever that you are comfortable with. You are not submitting this, isn't it? So show it in a way you are comfortable with, and that will help you illustrate the code you are going to write. Because once you get it wrong from here, you will struggle while writing your code. If you get it right from here, it will take you seconds to write your code. If you get it wrong from here, you will struggle while writing your code. And at the end of your struggle, you end up writing the wrong thing. So let's write the Python code, which is def recursive binary. So let's pass two things as parameter, array and what? Target. Is that understood? Let's pass these two as what? From the array we want to work on, and the target is what? Is the search value that we want to find in the array. Is that understood? So what is the first thing? The first thing is what? The before we go to the base case, if you look at the base case, we need to check if the item is found. That means we need to check if the target is equal to the mid value. So that means we must identify the mid value before the base case. Is that understood? That's what it means. That means we must identify what? The mid value before the base case. Because in the base case, we must check if the value is found. Is that understood?
Yeah.
So can you see that writing this one line of English is like writing it has encapsulated many lines of code in that just one line of English. Okay? And also, checking if the item is not found means you must have known the first index and what? And the last index. Is that understood? So, but before you find the mid value, of course, you must know the index, which is the first and what? And the last. Is that understood? So let's write that first is equal to 0. And what? Last is equal to what? Length of array. This time, let me use what? -1. Is that understood? What are we trying to do? We are trying to write the base case, isn't it? And don't forget, before you write the base case, you must know the what? The mid value. Is that understood? Then I write mid is equal to what? First plus last. Okay, floor divided by what? Floor divided by 2. Is this understood? Is this understood, everyone? Yeah. So according to our blueprint, we said if the data item is what? Is found. Then we write if target is equal to what? Array what? Array mid. Is this understood? Good. So if target is equal to what? Array mid. That means if what? If the mid value, if the value is found, isn't it? Or what? If the array is completely searched. At what point is the array completely searched? When the lower boundary is what? Greater than or equal to upper boundary. Is that correct? It will be the opposite of the iteration, isn't it? Because in the iteration, the condition is when you keep finding. But here is when you stop finding. When you keep finding iteration is when it's less than or equal to, right? But here, when you stop finding should be what? Should be greater than. Is that understood? So that should be first is greater than or equal to what? Is equal to last. So do you know that if I write equal to last, it's still the same thing? It means it can never be greater than last. It will always be equal to last. So whether I write greater than or equal to last is still fine. Then what do? Return mid. Is that correct? Now there's a problem with this code. Who can identify the problem? Who can tell the reason for the problem and how to solve the problem? So this is wrong because if the value is found, okay, it returns what? Mid. If it is not found, it also returns the index, which is wrong. If it is not found, it should return something else that is not an index in the array. Is that understood? So that means that instead of writing this, I should take this away from here, delete this, and write L if this, okay, then return -1 because -1 is what? Is not an index. So these are the two conditions for the base case. Is that understood? So that was why I was wrong. Although there's another reason that is wrong, but we'll come to that later. Let's move forward. Now that we have identified the base case, what are we going to do? Go to the what? Recursive case. How many conditions do we have in the recursive case? Two. So let's write the first condition, which is what? If the search item is greater than what? Mid value, isn't it? So that means L if target is greater than array mid. Okay. What should happen if the value is greater? The lower bound should change, not array. No, you're not slicing the array. Just change the lower bound. That was what I taught in the last class, right? The lower value what? To change, which is first, isn't it? So that means that first should be equal to what? Should be equal to mid plus 1, isn't it? Should be equal to mid plus 1. Is that understood? Then what does recursive case means? We will call in the point at which we will call the function, right? Then I have to return recursive binary, isn't it? Of what? There are two parameters passed in the beginning, right? Which is the array and what? And the target. Then I pass array and the target. Now, who can tell me what is wrong with this code now? So good. So what is wrong with this code is when you recall this function here, okay, then the value of false will turn back to 0. Will no longer be what? Mid plus 1. Is that understood? If you decide to pass another array as a parameter, then the index will what? Will change. The solution is what? The solution is to pass what? First and last as parameters instead of defining them in this function. So that means the solution is not to define first and last in this function. The solution is what? Is to pass first, last as parameters. So I have to pass first, last as what? As parameter. So what is the next one? Either I write else or elif. It's still the same thing, okay? Then that is the second condition here, which is when what? Target is less than what? The mid value. Is that understood? So elif target is less than array mid. Is that understood? Array mid. So what do I do? What changes? Last is equal to mid minus 1, isn't it? Then what do you return? We return the same thing, isn't it? But in this case, the last value has what? Has changed. And the last value has changed. Okay? So at this point, that is the end of the code. That is the end. It's as simple as this. So you want now to implement this. So let's declare an array to be equal to, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 10, 20, 30, 40, 50, 50, 60, for example. Then we now pass what? There's a return value, isn't it? So return value is equal to, then you call recursive binary of, so first index should be what? 0. That should be the first index. The last index should be what? The length of array, isn't it? The length of array minus 1. Is that understood? Then the array and what? Target. What is the target? The value to find. Let's assume we want to find a 70. A 76. We want to find this. Okay. Is that return minus 1 or the mean value, isn't it? Then write that if returned value is equal to minus 1, then what do? We print return. So we print what? Not found. Okay. Else, then what do you print? You print whatever you are asked to print in the question, maybe the returned value. You print the returned value. Okay. So let's run this code now. 76 is not found. So let's search for 30. 30 is found at index 10. Let's count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you see? So let me also search for maybe 2. 2 is found at index what? 1. And let me find 0. 0 is what? 0 is not found. I hope this is well understood.
Yes.
Thank you, guys.